Solve another continuity problem in this video. So in this video we have a function defined in three different ways. 2x times x minus 2 over x squared minus 3x plus 2 when x is not equal to 1 over 2. Negative 3 when x is 1, and 4 when x is 2. And what we want to know is A, where is f of x continuous, and B, what does the graph of f of x look like? So we'll start off with part A. Where is f of x continuous? Well, we need to figure out where the problem areas are. We can kind of assume that they're 1 or 2, but let's see how we might find that out. Let's focus on this expression here. So we have 2x times x minus 2 over x squared minus 3x plus 2. And let's try to factor the bottom. So remember, when we factor, we want to have numbers that multiply to 2 and sum to negative 3. So negative 1 times negative 2 is positive 2, and negative 1 plus negative 2 is negative 3. So that's how we can factor the bottom. So on the top we have 2x times x minus 2, and on the bottom we have negative 1 and negative 2. Okay, you can check that. This multiplies out to that. And now we can see that we can cancel x minus 2, and we're left with 2 times x over x minus 1. Okay? So it doesn't look like 2 might not be a problem point because there's no x minus 2 in the denominator. So let's go through and let's check. Okay, so start off with checking x equals 2. We're going to check to see if the function is continuous there. Okay, so we know that f of 2 is defined, so let's go ahead and see if the limit exists. The limit as x approaches 2 of 2x over x minus 1. Well, there's no problem here in the denominator, so we can go ahead and plug in 2. We get 2 times 2 over 2 minus 1, which is 4, okay? That's pretty good, actually, because at x equals 2, the function is defined to be 4. So we actually have all of our criteria for continuity, okay? Remember the first one, f of 2 exists. The second one, the limit as x approaches 2 of f of x exists. And the limit as x approaches 2 of f of x is equal to f of 2. And remember, this is just saying this limit is equal to 4, and f of 2 is equal to 4. And those two things are equal. So we meet the three criteria of continuity, so it's continuous at x equals 2. Alright, let's check x equals 1. So now we have the limit as x approaches 1 of 2x over x minus 1. And this is a problem. If we plug in 1, we have 2 times 1 divided by 0. And there's nothing that we can cancel. There's no x minus 1 up top. This is just wrong. This is just bad. Right? So even though the function is defined to equal negative 3 at x equals 1, the right and the left-hand limits are not going to work out to equal negative 3. So this total limit, this does not exist. BNE. And then remember, that's the second criteria of, this is the second criteria of continuity. The limit as x approaches 1 of f of x has to exist for it to be continuous, right? Since this does not exist, this means that at x equals 1, f of x is not continuous. So everywhere else is fine. There's no problems with the function. It's just at x equals 1, it's not continuous. So where is it continuous? Everywhere but x equals 1. Now for part B, graphing f of x. Okay, so let's put our graph down here. So the first thing we want to do is find some points that are going to be good to focus on. And x equals 1 is going to be a good point to focus on because we know that something strange is happening there. So let's write in x equals 1 and let's examine the right hand and the left hand limits at x equals 1. So first let's draw a tiny number line. Here's 1. Okay, now let's look at the limit as x approaches 1 from the right of 2x over x minus 1. And again, we're just trying to get a little more information about what's happening. So let's put in x here. So if x is approaching 1 from the right, x is larger than 1. That means that this on the denominator is positive. Up here, it's also positive, right? Because 2 times positive 1.1 or whatever, it's going to be positive. So this limit is basically going to be a number on top divided by something that gets really close to 0, but on the positive side. When you divide a number by a really small positive number, this limit is going to go to what? To infinity, right? How about, well, we can go ahead and draw that, right? So we're approaching 1 from the right, and we say that the function is going to infinity. So it's going to look like that, okay? Now let's look at the limit as x approaches 1 from the left of 2x over x minus 1. Now x is over here. We're approaching 1 from the left. X is less than 1. So now we have a small negative number on the bottom. The top is still positive, right? Because it's 2 times something a little less than positive 1. So we have a positive number divided by a really small negative number. That gives us negative infinity. So if we approach 1 from the left, we're going to negative infinity. So that tells us that we have a vertical asymptote at x equals 1. Now what we need to know is what happens to the graph way out at x equals infinity and x equals negative infinity. So over here, let's look at the limit as x approaches infinity of 2x over x minus 1. Now remember, we're looking at the limit as x goes to infinity. So what we want to do is we want to look at the degrees of the numerator and the denominator. What's the largest degrees? It's 1 on the numerator and 1 on the denominator. So what we have to do is look at the coefficients in front of those terms. 2 on top, 1 on the bottom. So that's what the limit equals. 2 on top, 1 on the bottom. That's just positive 2. So way out at infinity, f of x approaches positive 2. So let's say that positive 2 is roughly here. That means that the graph will look like this, right? What about the limit as x approaches negative infinity? 2x over x minus 1. So for this one, same thing, right? The degrees are the same. We're going to have a negative infinity on top and negative infinity on bottom. The negative signs cancel out. We're just left with the same ratio, 2 over 1. And that's equal to 2 as well. So way out here at x equals negative infinity, going to approach positive 2. Okay? That tells us that there's a horizontal asymptote at f of x equals 2. Okay? Now this wasn't the best graph. It's going to look something a little nicer like this, probably. But that's the main idea.